Okay, fourth grade. Hello, welcome to lesson 6 of module 6, fourth grade math. Today we're talking about area models and number lines to represent mixed numbers. Our objective for today is to use the area model and number line to represent mixed numbers with units of ones, tenths, and hundredths in fraction and decimal form. We're going to take a look at that concept right away with our application problem, which is on page 39 in your Learn books. So please turn to page 39 in your Learn books now. The table shows the perimeter of 4 rectangles. Which rectangle has the smallest perimeter? We have rectangles A, B, C, and D. The perimeter, which is all 4 sides of the rectangle added together, is listed in this column here. We have the perimeters written several different ways. They're all measurements of length, but they're written different ways, and we want to compare them to find the smallest one. We have 54 centimeters, 69 1/100ths of a meter, 54 meters, and 8/10ths of a meter. It's important to remember that 1 centimeter equals 1/100th of a meter. 1 meter divided by 100 gives us 1 centimeter. So in order to compare these numbers, we need to rewrite them in a way that we can compare them. They all need to be written in the same format, decimal, fraction. So let's start with 54 centimeters. If a centimeter is 1/100th of a meter, then we know that 54 centimeters equals 54 1/100ths of a meter. Now we can compare rectangle A. Let's make sure we mark our work too. Don't let Mr. Hansen get ahead of himself here. Let's be organized. This is rectangle A. Has a perimeter of 54 1/100ths of a meter. We can compare that to B now because we already know that rectangle B has a perimeter of 69 1/100ths of a meter. And since our units are the same and our denominators are the same, then we know that rectangle B is larger than rectangle A. It has a larger perimeter. We are trying to find the rectangle with the smallest perimeter. So B is out. We know that A is smaller than B. B can't be our correct answer. So I'm just going to, without making a mess, mark a little X here. I know B is out of the question because I've already found a rectangle that is smaller. Okay, so now we can compare rectangle A with rectangle C. Rectangle C says 54 meters. Now remember, rectangle A is 54 centimeters. And rectangle C, 54 meters. What we need to recognize, and good math thinkers are going to see when you understand decimal measurement, that right away, just based on the unit, I know that rectangle C is 100 times larger than rectangle A, right? It's not just a little bit bigger, it is 100 times bigger because a meter is 100 centimeters. So 1 meter is 100 times bigger than a centimeter, and 54 meters is 100 times bigger than 54 centimeters. So not only is 54 meters bigger than 54 centimeters, but it's actually, if we were to draw these rectangles out, it's off the charts. It's not even close to these other three. These other three are all a fraction of a meter, 1/100ths or tenths of a meter, whereas this is 54 meters. Now, rectangle C, not even close, because rectangle C would be written, if we were to write it in hundredths of a meter, it would be 540 hundredths of a meter, which really isn't even a helpful way to write it other than to compare that value to rectangle B. Okay, and rectangle D is written as a decimal. Let's change that to a fraction. 8/10 written as a decimal. Let's rewrite it as a fraction, which we all know how to do. 8/10 of a meter. We should be able to write it as hundredths of a meter, though, in order to compare our perimeters easily. So how do you convert 8/10 to 100 to 1/100ths of a meter? With a little multiplication. Change your denominator to 100 by multiplying times 10. And if you're going to multiply your denominator times 10, you also need to multiply your numerator times 10. So rectangle D is 80/100ths of a meter. Now we can find the smallest rectangle because we have them all measured with the same units and the same denominator. We have 80/100ths, 540/100ths, 69/100ths, and 54/100ths. All we need to do now is find the smallest numerator. And in order to do that, you just identify 54/100ths, rectangle A, as the smallest perimeter. We've written in numbers, and now we can write in words. Rectangle A has the smallest perimeter. Take a minute to make sure your part A looks like my part A. You can pause if you need to. Part B. The perimeter of rectangle C is how many meters less than a kilometer? Rectangle C how many meters less than a kilometer? Let's take rectangle C back to its original measurement, 54 meters, okay? C equals 54 meters. The nice thing about the metric system is it's easy to compare across different units, and it's easy to remember what different units are worth because everything operates in factors of 10. So if you know that there are 100 centimeters in a meter, that same information, that same scale will tell you that there are 100 meters in a kilometer. So the comparisons look like this, and you should be writing along with me. 100 centimeters equals 1 meter. 100 meters equals 1 kilometer. And you could go in either direction and continue. So if we need to find out how many meters less 54 meters is than 1 kilometer, our subtraction sentence to find the difference will look like this. It will be 100 meters minus 54 meters. And if we subtract and borrow, we're left with 46 meters. Written as a sentence, that will say that rectangle C, or it should actually say the perimeter of rectangle C, is 46 meters less than 1 kilometer. Now, just watch what I do for a second, and let's take a look at what happens if we try to represent a mixed number as a picture. Let's say that we have a mixed number of 1 and 22 100ths. How can we show that in pictures? Whole and part of a whole. We have one whole and one fraction of a whole. If we have tenths and hundredths blocks to work with, we know that we have one whole, and each of these squares is worth one whole. So we can start by shading in one whole square. 10 tenths. After we shade in our one whole, we also need to show 22 100ths, which means we want to shade in 22 out of 100 parts here. Each column is 10. So start by shading 2 columns completely. That will give us 20 100ths. And then after these 2 columns, we need to shade 2 more 100ths. For a total of 22 100ths. So this picture shows us one whole and 22 out of 100 parts of a whole. 1 and 22 100ths. We're also going to explore how we can show this same value on a number line. You are going to do that with me, and you're going to take out the template for that number line, which is on page 47. Turn to page 47 in your Learn books, please. We're going to work with the same mixed number to show it on a number line. Let's label our number line first. Let's label our wholes. We have 0, 1, 2, and 3. The value that we want to represent is 1 and 22 100ths. We're starting, of course, at 0, and we want to mark a point on this line that is 1 and 22 100ths. So let's start by traveling from 0 to 1. That's easy, right? Let's take care of our whole first. Draw a neat arrow that represents plus 1. We started with 0, we've added 1. Now we're at 1. We still have to represent 22 100ths more. We know that if we were to use a number bond to kind of break out 22 100ths, we can separate it into tenths, right? Because this 2 here is in the tenths place. It represents tenths. 2 tenths, which is the same as 20 100ths. And then we can break out our 100ths. We have 2 tenths and 2 100ths. So from 1, in order to get to 22 100ths, we need to travel 2 tenths and then 2 100ths. Each of these lines represents 1/10 of a whole. There are 10 equal spaces between our wholes. We're going to travel 2 tenths, so that's 2 of these small lines from 1 to 1 and 2 tenths. That represents an additional 2 tenths. Sorry, I messed that up. That should be 0.2. 0.2 or 2 tenths, 0.2. And from 2 tenths, we want to travel 2 100ths further. Now that's a little tricky because between each tenth marker, there are 10 hundredths markers. But if I tried to mark them right now with my marker, and even if you tried to do it in pencil, it's going to be very hard to read. but we know that 2/10, or excuse me, 2/100ths, if we visualize there being 10 lines, we can find a spot that is clearly more than this line that represents 1 and 2/10, and we will mark it as 0.02, 2/100ths. So that point there represents 1 and 22/100ths. 1.22 in decimal form, or 1 and 22/100ths in fraction form. Let's try the same thing with a different number. Move down to a clear number line on your template, and let's represent 3 and 46/100ths. So let's show that fraction, that mixed number right here, 3 and 46/100ths. Since we are representing an amount that is greater than 3, let's start our number line with 3. Our wholes are 3, 4, 5, and 6. So if we are going to start at 3, we've already represented our 3 wholes by starting our number line there. So that part is complete. We need to show 46/100ths. And again, if we separate 46/100ths using a number bond into tenths and 100ths, we have 4/10ths and 6/100ths. So from 3, travel 4/10ths, 1, 2, 3, 4. Represent that with an arrow, because we don't want to draw our point yet. And that arrow represents plus 4/10ths, which can be shown as 0.4, right? If we're using decimals, 3 and 46/100ths is the same as 3.46, which is also read as 3 and 46/100ths. I just say 3 and 0.46 to represent the decimal during a lesson. They both represent the same value, and they're read the same way. So our 4/10ths is shown right here, right? 0.4 equals 4/10ths. 4/10ths, 4/10ths. Now we need 6/100ths. We know that 6/100ths is going to, that travel is going to take place in between 4/10ths and 5/10ths. There are 10/100ths in that space. And if there are 10/100ths in here, and we are representing 6, 5/100ths would be right in the middle. So 6/100ths will be just a little bit further than the middle. Again, it's very hard to show these small amounts, but that's an accurate location, and that little amount shows 6/100ths, or 0.06. 0.066 100ths. 3 and 46/100ths. 3 and 46/100ths. 3 and 46/100ths. Okay, 4th grade, showing these mixed numbers on the number line is one part of your exit ticket that you're going to work on today. Another part of the exit ticket is showing the equivalent fraction and decimal for something in unit form. 1, 1, and 2/100ths. 1, 1 means 1 whole. 2/100ths is going to go in the hundredths column, which is not here, but here. It's important to remember that we have ones, tenths, and hundredths. Tenths go in this first place after the decimal, and hundredths go in the second place. So if it tells you in unit form that you have 2/100ths and 1, 1, It didn't say any tenths. If it doesn't give you a number for tenths, that means 0 tenths. So we have 1, 1, 0 tenths, 2 hundredths. Part B says 1, 1, and 17 hundredths. 1, 1, and 17 hundredths. Ooh, let's not forget to show these in fraction form. 1 and 2 hundredths. 1 and 17 hundredths. If you're showing hundredths, just make sure that 100 is your denominator. 2 ones and 8 hundredths looks like 2.08 as a decimal, and 2 and 8 hundredths as a fraction. 7 ones and 70 hundredths looks like that, or like this. But a more simplified way to write it is 7 and 7 tenths, which is an equivalent value to 7 and 70 hundredths. They are worth the same amount. This is exactly what you're going to need to do excuse me, in your exit ticket today. Be sure to refer back to this page if you need to complete your exit ticket. Thank you for all your hard work. Please be sure to submit this and turn in this assignment through Google Classroom, and I will see you tomorrow. Don't forget to like and subscribe.